Hey, what's up, guys? This is Chung here again. Let's take a look at another weekly contest problem, number 1642, furthest building you can reach. Okay, so you're given like an integer of array, heights, and some bricks and some ladders, and you need to start your journey from building 0 to the furthest building you can get. I think there's a very uh, interesting, like funny illustration here, like a meme here. I like this one, by the way. So the rule is like this. Uh, if your current building is higher than the next buildings, you can just simply jump to that building. You don't need to use anything, either higher or with the same height. But if the next building is, if your current building is lower than the next buildings, you have to either use the bricks, right, with the difference, or you can use any ladder to get to the building. Okay, and then it asks you to return the furthest building index you can reach if you use the given ladders and bricks optimally. Okay, so I mean this problem, it's like I think it's more like a greedy problem. Mm, I mean this problem can also be solved, by using a DP, but given like the constraints here, as you guys can see here, so the ladder and the heights is pretty big, and 10 to the power of 6, and the brick is even bigger, 10 to the power of 9, which means if you use like a traditional DP here, so it means that from the current, like if you do a DP here with the current the building's index I, right, and then you need what? You need another like the bricks, right, the remaining bricks and the remaining ladders, right? So at each of the buildings I here, you either use like a brick or you either use a ladder. But obviously, that's gonna be TLE in this case because so the total combinations for this is too big, right? Even this height itself is gonna be 10 to the power of 6 plus the bricks and the ladders, right? The ladder is same as this heights. So this will TLE. That's why we have to find another solution for this problem. Actually, I already tried this. I mean, logic-wise, this thing works, but it will TLE later on. So another way, so we have to use what? We have to basically then it's telling us we have to use a greedy solution. So and then what's gonna be the greedy rule here, right? So as you guys can see here, right? So the ladder is more valuable than the bricks, right? But when should we use the ladder? That's the problem. We don't want to use the ladders. Mm, I mean, because I was thinking maybe I should like loop through all the heights and then I'll try to find like the biggest difference, the biggest height difference, and then I'll use the ladders there. But then it turns out that may not be the case because we may not even be able to reach that building, right? So if we use that rule, I mean, we will maybe it will end up we will be never and we'll never use that ladders because we'll never reach that building. So the correct greedy way is that we'll use the ladders. I mean, when we have to use it. So what does it mean? It means that let's say we try to use the bricks. We try to use the bricks to get to a building which all the bricks have been used up. Okay, so then means that okay, so between let's say we have a building 0 to 5. Okay, so once we get to 5 and then we find out okay, so all the, all the bricks we need from 0 to 5 has already exceeded the bricks. So it means that between 0 and 5, we have to use a ladder to help us to get to 5. Then, but which ladder, which buildings we need to use the ladder? And then it's obviously we want to use the ladders on the biggest height difference. So for that, we simply do what? We simply use a priority queue to maintain uh, to maintain to maintain the difference of buildings we have seen so far. Okay, and we just pop that thing out of the priority queue, and then we will be uh, removing that bricks, right, from this needed, the total bricks needed, and then we keep doing it until we have used all the ladders, and also the bricks are also being used up. Cool. So that's gonna be our basic uh, idea here. So like I said, priority queue, right? So the priority queue, we have answer equal to 0. Okay, and then I'm gonna have a length equals to the height. So mm, so for I in range of 0, okay, range 0 to n minus 1. So why I'm doing the n minus 1? Because I need to jump to the last buildings. So from the current building to the next building, right? So that's all I need to know. Hmm. Yeah, I mean, if we can jump, if even this I the n minus 1, sorry, if even this n minus 2 uh can go through, then it means that we can jump to the last buildings. So in the end, we can just simply return n minus 1. Okay. So otherwise, for each of the difference, I'm going to calculate the difference here. So the difference is going to be from the the next the next building to the current building, right? To the current buildings here. So first thing first, we check if the difference is is equal or smaller than 0. Then it means that we can go to the next building for free, right? So I will just continue since we're like looping through all the buildings here, right? And then yeah, so I also need to have like total bricks. Okay, total bricks equals to 0. So else, right? Else we are gonna increase the total bricks, okay, plus difference, and also I'll be pushing this priority queue, this difference to the priority queue here, heap push, right? Priority queue. And since we're trying to maintain like a max queue here, so that's why I have to use like the negative number of that, right? Because in Python, the heap by default is a minimum queue. So to make it to use it as a max queue, I need to use a negative value here. And if needed, right? If needed is greater. Sorry, it's not needed. It's the total bricks is greater than the bricks than the bricks. Okay. Then we do what? We check if we have any, so at this moment, right? So it means that we have to use a ladder. So we check if the ladder is, uh, if the ladder is 0, okay. Basically, it means that we have used up all the ladders and we cannot, mm, we cannot jump, we cannot jump to the next building, right? So because here we're calculating the bricks we need from the current building to the next building. And here it means that, okay, we don't have any ladders left, and the total bricks is greater than the bricks we have. So we simply return the I because it means that this is as far as we can jump. Okay. Else, right? Else we do what? Else we know, okay, we can use the ladder here. So we use the ladder, so we do a ladders decrease by 1, right? And then we're gonna use ladders to climb the the highest, the biggest difference in the total here. So we do a, and after that, so the total bricks needed will be decreased, okay, by the heap queue dot heap pop, right? The priority queue. So here, notice here I'm using a plus here, not minus. So why is that? Because since that we are storing the negative values here, right? So I mean, if it should be a minus, but here I also need to do a minus, right? But so that's why I'm just using a plus here. That can handle it for us. Cool. And then, I mean, if everything works fine, even we can jump from the second last building to the last one, and then we know, okay, we can jump all the buildings, so we just simply return a minus one. All right, so let's run the code. Heights. Okay, cool. Submit. All right, cool. I mean, so time complexity, right? So I think it's pretty straightforward. So it's n log n, right? So because we have like n buildings in total, and the priority queue here, we are maintaining like at most n buildings here. So it's gonna be a log n. Yeah, cool. Yeah, I think this one I think it's okay problem. The DP thing is a little bit misleading because given like this pre pretty big constraints here. And other than that, I think you just need to come up with like a feasible uh, strategy of when to use the bricks and when to use the ladders. And once you have come up with that strategy, and all it's left is just to use the priority queue and to implement your strategy. Yeah, cool. Yeah, I think that's it for this problem. Yeah, thank you so much for watching this video, guys. Stay tuned. Have a good night. Bye bye.